Hello everyone and welcome back to Infinix Coaching Center. In today's video, we are going to learn about exponents and powers. So to begin with this, you should know two technical terms. The first one is base here and the second one is power or the exponent. So I have an example over here. This 5 I have written in red is the base and the number 3 which is written in blue color is the power. So 5 raised to 3. What this means is the base is multiplied by itself exponent number of times or power number of times. Here it is 3, so 5 is multiplied by itself 3 times. 5 multiplied by 5 multiplied by 5. Next we will go to the basics of exponents. I have given some examples over here where I have taken the base number as the same one and I have just changed the power number. So let's see, 10 to the power 4, which means 10 is multiplied by itself 4 number of times. So 10 multiplied by 10 multiplied by 10 multiplied by 10. Similarly, I have done 10 to the power 3, 10 multiplied by itself 3 times, 10 to the power 2 where 10 is multiplied by itself 2 times, 10 to the power 1, I have just 10 over here, and the last one is 10 to the power 0. Now remember that whenever a natural number is raised to the power 0, it means that the answer will be 1. We will learn about this in detail in some other video. For time being, you just have to remember that 10 to the power 0 means 1. Let's go to the next one, expanded form of natural number. You have been doing this for a long time now, but it is just that you were not introduced to exponents and powers. So today we are going to look at this from the exponent and powers perspective. So I have a number here 52. This 52 I can write as 50 plus 2. 50 I can expand it as 5 multiplied by 10 plus 2 multiplied by 1 will give me 2. If I add this both, I will get the number that is 52. So 5 multiplied by 10 can be written as 5 multiplied by 10 to the power 1 plus 2 multiplied by 1. Next I have 152. So this 152, it can be written as 100 plus 50 plus 2, wherein I have 1 multiplied by 100, that will give me 100, 5 multiplied by 10 will give me 50, 2 multiplied by 1 will give me 2. So I can write this 100 as 10 to the power 2. So now the exponent form is here, 1 multiplied by 10 to the power 2 plus 5 multiplied by 10 to the power 1 plus 2 multiplied by 1. Next number I have 25,968. So I will expand this to I have 20,000 plus 5,000 plus 900 plus 60 plus 8. So this 20,000 can be written as 2 multiplied by 10,000, 5,000 can be written as 5 multiplied by 1,000, 900 can be written as 9 multiplied by 100, 60 can be written as 6 multiplied by 10, and 8 can be written as 8 multiplied by 1. When you add this all, you will get the number 25,968. Now I will write the exponential form for this, that is 2 multiplied by 10 to the power, there are 1, 2, 3 and 4 zeros, so 10 to the power 4. Next I have plus 5 multiplied by 10 to the power 1, 2 and 3 zeros are there, so 10 to the power 3. Next 9 multiplied by 10 to the power 2. Similarly, 6 multiplied by 10 to the power 1 plus 8 multiplied by 1. So I hope the exponential form is more clear to you now according to the exponents and powers form. So we'll go to the next slide that I have here. Now we will start with the laws of exponents. So the first law states that a to the power m multiplied by a to the power n is equal to a to the power m plus n. I have given an example for you to show this. Now the example has two sections. The first one is a general one, how we will solve it. Second one is using the laws. So the first one says that 2 to the power 3 multiplied by 2 to the power 4. If you see over here, the base is same. So I can write this, I will expand this as 2 to the power 3. So 1, 2 and 3 times I have multiplied 2 by itself. Second is 4. So 1, 2, 3 and 4. So the answer that I will get is 2 is base. I have written here how many times it is multiplied by itself, 1, 2, 3, 4, 5, 6 and 7 times. So 2 to the power 7. Now using the law, we have, this is where the law comes into picture. You can save a lot of time. 2 raised to 3 multiplied by 2 raised to 4. If you see over here, the base is same. So using this law, I can write the base over here again. 2 I have written here. I will just add the powers. 3 plus 4 is equal to 7. If you see, both the answers are same. So this is the first law or the first identity. Second one is a to the power m upon a to the power n is equal to a to the power m minus n. So example is, first one I have taken 4 to the power 5 upon 4 to the power 3. So I will just expand this. I will write 4 multiplied by 4 multiplied by 4 multiplied by 4 multiplied by 4. That means 4 multiplied by itself 5 times. That means 4 to the power 5. Next I have written 4 multiplied by itself 3 times, 4 to the power 3. So what I will get is this 3 will cancel with the top 3. So whatever remains I will write over here, that is 4 into 4. I can write this as base is same. So it is multiplied by itself. So I will write base here to the power 2, 4 to the power 2. Now using the law, we have same example, same numbers I have taken over here, 4 to the power 5 plus 4 to the power 3. So what I will do is I will use this law. I can see that the base is same. So I have taken the base same here. I have written the base. Then I have just subtracted the powers. So 5 minus 3, that is 2. So you can see that the answer is same, and this is the law. Using the law will save you a lot of time whenever the number gets more bigger and bigger. Now let's start with the third one. The third law states that a to the power m to the power n is equal to a to the power m multiplied by n, product of the powers. So in general, how do we use it? 4 to the power 2 to the power 3. This means I will write it in the expanded form, the normal one. This means that this number that is there inside the bracket is multiplied by itself 3 times. So I will write 4 to the power 2, 4 to the power 2, 4 to the power 2. Now I will expand each of this. So 1, 2 of this, 1, 2 of this, and the last one 4 to the power 2 I have written over here. So if I write this in general, I can say that the base is same. These are the bases I have over here. So I will write 4. How many times I have the number getting multiplied by itself? 1, 2, 3, 4, 5 and 6 times. So now it is 4 to the power 6. Using the law, we have, now I have taken the same example. If you see same numbers are there, this will make you understand why the laws are very important. Every time you don't have to do this calculation, you can directly use the law. So 4 to the power 2 to the power 3, the law says that you have to multiply the powers. So I have taken here 2 to the 2 multiplied by 3 is equal to 6. You see over here the answer is same, hence the identity is verified. Next one is a to the power m upon b to the power m is equal to a upon b whole thing to the power m. So over here, if you see, the base has changed whereas the power is same now. So what we will do in this case is I will take the example that is 3 to the power 2 upon 2 to the power 2. Let's see, I will expand this 3 into 3 upon 2 into 2. I have just solved this for you. I have simplified this example for you. It is 9 upon 4. Okay, there is one more way to solve this. 3 raised to 2 upon 2 raised to 2 can be written as 3 multiplied by 3 upon 2 multiplied by 2. So what I will do, I will group this now together, that is 3 upon 2 multiplied by 3 upon 2. So what it becomes is, this becomes my base, that is 3 upon 2 becomes my base, and it is multiplied by itself 2 times. So 2 will be the power. So hence now using the law, we have, if I use the law, I could directly use the law here because I can see that the powers are same and the base is different. So what I will do is 3 to the power 2, 2 to the power 2. This numbers which I have here, I can write this as 3 upon 2 whole thing raised to the power 2. See, it has saved me almost 2 steps over here. So now let us go to the next one. A to the power m into b to the power m. Here the base has changed whereas the power is the same. It says that this will be equal to ab to the power m. It says that you have to multiply the base whereas you have to keep the power same. Let's see how it is actually used in the problem. 2 to the power 3 multiplied by 5 to the power 3. I will expand this here. So 2 to the power 3 means 2 is multiplied by itself 3 times. So 1, 2 and 3. Now 5 to the power 3 means 5 is multiplied by itself 3 times. So 1, 2 and 3. Now I will group these numbers together. So 2 and 5. 2 multiplied by 5 I will write here as one group. Then again this and this will come here, and this will come here. So I have 3 groups now. 3 groups are there. One is this, second is this, and the third one is this. If you see here, both of them have the same number. So I can say that because of multiplication, I can say that 2 multiplied by 5, that is this becomes the base, raised to the power 3 because it is multiplied by itself 3 times. Now using the law, I can directly state that 2 to the power 3 multiplied by 5 to the power 3. I know that the base is different but the power is same. So I can say that 2 multiplied by 5, that is base multiplied by base raised to the power the common power that I have, that is 3. See, if you see, I have saved this much time over here. Now let's conclude this chapter capsule, a small capsule in which everything is summarized of the entire video. The first one is over here. First law is of multiplication. It says that whenever the bases are same and the powers are different, you have to add the powers and the base will remain the same here. Next is, if for division, whenever the base is same and the powers are different, for division always subtract the top power here, that is m minus n. You have to do the subtraction for this. Now if a power is raised to another power, so the base will remain the same and the powers will multiply by each other. Next we have the division. When the base is different and the power is same, you just have to write the base, that is a upon b in this case, raised to the power common power that I have, that is m. And the final one is a raised to m into b raised to m. The base is different whereas the power is same for both the numbers, so I will multiply the base and I will raise it to the same or the common power. Now there is just one small thing I want to add up. The sixth one is the first one that I had actually done not as a law, that is any number to the power 0, that is a raised to 0, will be equal to 1. So students, this is all I have for today's video. I hope that you find this video useful, and please utilize this time that we have got because of whatever reasons the world is facing. I know it's a bad phase for everyone, but remember, in every bad thing that happens to us is a good thing which tells us that we should not repeat this mistake again so that we don't suffer. So thank you so much for watching the video, and I will see you in another video, and make your life more and more simple. Thank you so much.